you're fine. You get away with a lot more things.
Oh, wait. You don't have to worry about it. Unless you want to find another way.
Alright, today we're going to learn how to graph a square root function. Now, we have simplified radicals before. We have also turned a rational exponent into a radical. Remember where we had a fraction as an exponent and then we turned it into a square root? Today we're going to learn how to graph them as a function. It is super easy. Like the easiest of all the ones that we graph. You just have to pay attention to what you plug in. And since square roots, we usually use those on perfect squares, right? So that we can get a whole number. We're only going to plug in perfect squares. Now, the other day, when we did the quadratic formula, we were talking about taking the square root of negative numbers. Can we take the square root of negative numbers? No. So we're never going to plug in a negative x value. It's going to be super easy, super fun. Let's do this. Alright, so square root functions. This guy right here, this is our parent function. This is the alpha, the omega, the beginning and the end. This is our parent function. And we are about to learn how to graph him. Or her. It.
Is alpha the boy and omega the girl?
Not always, but alpha is a more masculine, omega is more feminine.
What's that? Oh, no, I just
Like
saw
the
a movie
wolf,
one
like
time.
in a wolf pack.
There's an alpha and the omega, so the alpha is the leader of the pack, the omega is the female that matches with the alpha, and then there's a beta, which is the second command.
Omega sounds better. So, like, would beta be their kid?
No. It's the second in command.
So, like, if the alpha died, it would be the beta and be the
The
alpha?
beta would have to take over.
Yes.
Oh.
So, what's after beta? You
You
go
used to watch Teen Wolf.
No, that's
Beta
not-
someone else. You're not this wolf. I am. Okay.
It sounds like birds.
Megan, what'd you say? You said sounds
Alpha
like
bird,
birds.
omega bird.
Animal Planet one time.
Animal Planet do have good stuff. I like the Animal Planet. That's the business.
You want to see animal fights.
Where the Snoop Dogg.
Okay, so what you do to graph these is you make an XY table. And for your x values, you only plug in perfect squares because we want to take the square root and get a whole number. So our first perfect square is 0, 1, 4, then 9.
We're always going to use these numbers.
Not always, but for the most part. Then we're going to take the square root of it. So we're going to plug in 0 here. What is the square root of 0? Magic! What's the square root of 1? What's the square root of 4? What's the square root of 9? Look at us go, we know math. Yes. You pick perfect squares every time. And I was about to say, let's make a note about that. Thank you for asking, so I remember to actually say it. So plug in perfect squares. And we're going to talk about what happens if you have numbers or stuff on the inside, which we'll get to that in a minute. So what we're going to do is we're going to graph this beautiful, beautiful function. And he is a special function. Now, with the way this function is right now, can we plug in negative x values? No, you can't. So we're going to start at 0, 0, and we're going to put a dot. That's our first point, 0, 0. Yes?
So it's going to be like are we like down with parabolas?
Yes. This is a new function. That's why it's our new unit. Alright, then right 1, up 1. Right 4, up 2. And right 9, up 3. Now, we did not plug in any negative x values because we can't. So, it stops here, or starts here, rather, and then goes that way.
I saw one of those on the test. It was like upside down. From the top.
That was just half of the parabola. And this is half of a parabola, but this is the graph of a square root function. So, it looks like
So it's
A
a
parabola cut in half.
That's just.
so it's a pair.
Hater?
Pair.
You get what he said?
It's a pair.
Does it have a.
I know.
Now,
I'm an intelligent person. Alright, so does anybody have any questions? That's all you do. You just plug numbers in and graph it.
It's kind of like, what we did last week. What's it called?
Quadratics?
Yeah, like
Yeah. And this base form, the vertex form, is almost the same thing as our quadratic vertex form. Remember when we had 8x, x minus h quantity squared plus k? It's the same thing. So your vertex is still hk. And by vertex, what they mean here is your starting point. So since we didn't have anything on the inside, our hk is 0, 0. That was our starting point. Magic! And then you use your perfect squares from there. And the rules of A still apply. So remember when our parabola, when A was greater than 0, it opened up. And when it was less than 0, it opened down. So if A is greater than, not equal to, Blair. If A is greater than 0, it's like this. Don't draw the line under it. What is it? Who are we missing?
Robert.
And, okay, and Juliana. Alright, and if A is less than 0, it's going to look like this. So it just flips over. Same thing. Crazy. Yeah. Are we ready to practice some?
No.
Are we sure?
yes.
Anybody have any questions? Yes.
So like, when it says like, they're not gonna put any number or like, so when they put the numbers in, and it's like, okay, like A, whatever, however you say it, I don't know how to say it. And then H is like 4, and then K is like 10. Your vertex is 4. So you put it there, and then you go from that 4, or you go from 0 up.
The vertex.
She confused me.
She knows what.
I'm trying to figure out, like, you know how you use that formula right there, like the equation right there. Why we didn't do it at the top? What do we just do? I know we just made a table.
We graph the parent function.
Oh, so that was what we were graphing?
So our parent function is the square root of x. Our vertex here is 0, 0 because we don't have an h, we don't have a k, so we started at 0, 0. We don't have a number outside, it's just 1, so we know we're going to go up because it's positive. So then we plugged in our values. It's perfect squares, so you would go right 1, up 1, right 4, up 2, right 9, up 3.
So when there's numbers, we're going to use that.
Yes.
flavor.
Ready? Turn it over. 63b. And that's what I'm about to show you, is how to use the equation. Alright, example 1. Graph each function. And our first one that we're going to do is f of x equals the square root of x minus 3. Or do I want to do it on the outside? I want to do it on the outside first. If you need whiteout, I have it. Don't draw the radical all the way across. So the square root of x minus 3. Not the square root of x minus 3. The square root of x minus 3, they'd both be under the radical. The square root of x minus 3 is the square root of this minus 3. Anybody else need whiteout? Okay. Alright, so we're still going to plug in perfect squares. But what do you think that minus 3 is going to do to our graph?
Make it a negative.
Shift down.
It's gonna make it.
We're going to subtract it by 3, but it's going to shift down how many units? 3. Now, this is still a positive. This number out here, so it's still going to go up. But I want to plug in our x values just so we see what the table will look like, okay? So we have x, y. Now, I said we use perfect squares unless there's something under the radical. Is there anything under the radical? No, so we use perfect squares. 0, 1, 4, 9. Alright, so let's plug in 0. What's the square root of 0? It was 0 minus 3? Negative 3. Alright, let's plug in 1. What's the square root of 1? And what's 1 minus 3? Alright, let's plug in 4. What's the square root of 4?
2.
And 2 minus 3? And the square root of 9?
3.
And 3 minus 3?
0.
Straight line.
You think it's a straight line?
Oh, right. I don't know why I thought that would be a straight line.
Just because the y's are increasing at a steady rate, or they're increasing, doesn't mean the x's are. So be careful. Be very, very careful. You never know when it'll jump out and kill you.
Dang.
Now, we supposed at the beginning that it was going to move down 3, right?
Oh, it's just
So-
go back.
Let's see what it does. We go 0, negative 3. So start here, down 1, 2, 3. Alright, 1, negative 2. Right 1, down 2. 4, negative 1. Right 1, 2, 3, 4, down 1. And 9, 0. Right 1, 2, 3, 4, 5, 6, 7, 8, 9. A para. Does everybody see what we did?
Yes, ma'am.
Now, using what we know about the vertex form, h is our x value of our vertex. And did we have a number under the radical? So it's 0. And then it moved down 3. So did we go down 3? And then we went right 1, up 1, right 4, up 2, right 9, up 3. That's all you have to do. It's easy. Now, I forgot to mention domain and range, and I want to talk about that because we're going to have to label it on our homework. So the domain of this is your x values have to be greater than 0 on your parent function. Because we can't plug in any negative x values. You can't take the square root of a negative. So it's x when x is greater than or equal to 0. For your y values, we didn't go below the line, so it's y when y is greater than or equal to 0.
What if it's not where they don't put it in?
I'm going to show you. So then this one, our domain, did we plug in any x values less than 0? So it's x when x is greater than or equal to 0. Because our x values are all greater than or equal to 0. Does everybody understand? Yes.
Can we do a problem where we do have to plug in a number?
This is what we're going to do in a minute. And then range is y when y is greater than or equal to what? What's our y value?
You got more than next period?
Yes. Put it under that table up there, please. Thank you. Alright, what are our y values greater than? Negative 3, yeah. And that's it. That's all you do. So how would we move the parent function up?
Make it to the negative 3 positive.
Add 3. And you guys do the same. So how could we move it left or right?
Put it inside.
Inside the radical. Alright, let's do that. Let's go crazy. Alright, I want to do the square root of x minus 4. Now, you can do this two ways. You can plug in values. Now, you won't plug in perfect squares this time because you have to get 0 under here. You have to get 1 under here. So you're going to manipulate your number so that you get perfect squares under the radical. So what minus 4 would give us 0?
Positive.
So we would start by plugging in 4. And then what minus 4 would give us 1? 5. And then what minus 4 would give us 4? 8. So you see how it would be a little bit different this time? Because you want to get perfect squares under here. So another way that you can do it is you can use your vertex. So what is my vertex? What do you guys think it is? But what is my starting point?
0. No, negative 4.
Y'all think it's negative 4?
Positive.
Well, let's look back at our vertex form, or base form.
Negative 2.
It's the opposite of h, because it's h, so opposite of h. So what would our base, where would we start at? Positive 4. And 0, because we don't have a k outside. So let's go right 4. 1, 2, 3, 4. Did everybody see how we got that? Alright, then we use our perfect squares. Before, we've just been going right 1, up 1, right 4, up 2. Do it from your vertex. So we're going to go right 1, up 1. From my vertex, I'm going to go right 1, 2, 3, 4, up 2. Then I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. Shoo. Ah, Blair. Pardon? You want to see what the table would look like? So I would start at 4, and then I would go to 5, and then I need my next perfect square to be 4, so I would go to 8, and then I need it to be 9, so I would use, what, 13? 13 minus 4 is 9? Alright, so then 4 minus 4 is 0. The square root of 0 is 0. 5 minus 4 is 1. The square root of 1 is 1. 8 minus 4 is 4. The square root of 4 is 2. 13 minus 4 is 9. The square root of 9 is 3. So that's what your table would look like. And that's the same thing we have here. Yep. Pardon? Yeah. But you can do it either way. I gotta remember to show first period that tomorrow because I didn't today. So a minus on the inside moves it right. How would we move it left? A positive. Now, what do you think it would do if we had a number on the outside?
Multiply.
What would it do to the graph?
Make it go higher.
Like this? Or like this?
Make it longer.
Steeper, right? Okay, so let's try that and see what happens. Alright, so f at x equals, let's go crazy, negative 3 times the square root of x. And I want to do a table just for funsies.
But can you also show us what the vertex is?
Are we ready? Okay. So, first we start by plugging in 0. Alright, what's the square root of 0? And what's negative 3 times 0? Alright, now let's plug in 1. What's the square root of 1? What's 1 times negative 3? Alright, let's plug in 4. What's the square root of 4? And 2 times negative 3? And square root of 9?
3.
And 3 times negative 3 is?
9.
Alright, let's draw our graph. Graph. Alright, now is my vertex or my starting point still 0, 0? Yes, because there was no H and K. And then I go right 1, down 1, 2, 3. Right 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. Oh, Blair. So it's the opposite of a parabola, right? But it makes it steeper in the terms of the square root. And then we go right 9, 1, 2, 3, 4, 5, 6, 7, 6. Now, how could we do this using vertex form? Do you guys remember when we had vertex form with a quadratic and we had a number on the outside and I told you to multiply the perfect squares times the number? It's the reverse of that. You multiply the square roots times the number. So you still go write your perfect squares, but you multiply the base by this number. So we would go right 1, and then you would normally go down 1, or up 1, but you multiply it times this number, so you go down 3. Then we would go right 4, and we would normally go up 2, but you multiply it by this, so you go down 6. Right 9, we would go up 3, but you multiply it by this, and you go down 9. So you multiply your counting numbers by that number up front. Questions? All right, you need 8 colors for what we're going to do next. 8. Ocho. Yes. Oh, yes, yes, yes. For A? All right, so let's go over the domain. Thank you. The domain and range for this again. Domain, x values cannot be less than 0 here. So it's x is greater than or equal to 0. The range here is it's going to be greater than -3 because that's our smallest y value. So it's greater than or equal to -3. Now let's look at B. What's our domain for B? Where do we start with on our x's? 4. So x when x is greater than or equal to 4.
Okay,
So it's where your vertex is. Yeah. And then your y values, what do we get for that? 0. Y when y is greater than or equal to 0. Now, on C, our x values are still 0, because we didn't plug any negative x values, did we? But what would our y be? Yep, less than or equal to 0, because it's going down. Thank you, Zoe, for reminding me to do that. All right, so you're going to need 8 colors. I've got to use my markers. Why do you need to use my stuff? Didn't you have your own stuff this morning? I'll get my pencils off my ruler thing. For B, the range was greater than or equal to 0. In this range. I'm sorry, Emily, I'm sweating over here. Yes. Why are you looking at me? Six, 7, 8. Alright, so what we're going to do is we're going to use it each, because this was in color to begin with, but our copier only copies in black and white. So we are going to draw a color over each line. So I'm going to start here, and that one's going to be this fuchsia color. Because we want to be able to match. Yeah, so I want to be able to see like what I'm doing. Your colors don't have to match mine. Are we ready?
Yes, ma'am. I'm ready. They put up the colors after the chemistry.
Keep them. Keep them for now, sir. Hey, my soccer team won Friday.
Who's that play?
Tottenham. Remember I told you it was our
Oh,
big
yeah, the
rivalry?
rivalry.
Yeah, we won. I cried. Ran up and down the hallway screaming. Not even lying. We ready?
What was the score?
1-0.
Did it go into penalty kicks or was it like?
It only goes into penalty kicks when
Yeah.
it's like the World Cup and stuff like that.
Really?
Yeah. Or when it's like the finals for Champions League. Well, because you, at the end of regular time and things like that, you have extended time.
Yeah.
And then after extended time, if no one still scored, you have 2 rounds of extended time and then you do penalty kicks. So it doesn't do that in regular season. You just have a draw and you get a point. Alright, so we are going to match the function to the graph. Now, A is our parent function. So which of these looks like your parent function?
Zero.
The yellow.
Zero.
The yellow.
Mine is this fuchsia color. It's this one right here. So we're going to write an A beside it, and then you're going to take your color and you're just going to squiggle so you know which one it is.
Wait, kind of like kind of highlighted.
So, like, would B be the, your yellow one?
B would be my yellow one because it's flipped over, yeah.
Yeah, color there.
It's this one right here.
And then.
What did you think fuchsia was?
Would be the one under
Sitting in a Pokemon game, obviously.
I didn't know future was a word.
Alright, so +5. Now, +5 is like, and it's on the inside. So we said when we had -4, it moved it to the right. So what would +5 do? To the left, how many?
So it'll be.
It'll be my red. So the one that moved left 5. So what would the -5 do?
It would move it onto the one underneath.
Yeah, the one underneath A. So that guy, that guy right there. Just think, kids, we're almost done with the school year. We can do it. Alright, so E is +5 on the outside. So +5 means it moves it up 5. So that would be this peachy color up here. -5 would move it up or down.
Now it's just blue. Wait, that.
My green. Oh, Blair. No. It's part of it. Alright, now, we saw that when we multiply it by a whole number on the outside, it makes it, like, steeper this way, right?
Yeah. Or
So, is it going to be this high one, or is it going to be this flat one? The high one. So what would the fraction do?
Make it
Yeah.
narrow.
Make it the narrow, the flat one. Awesome. Any questions so far? Okay, so now at the bottom, do you see where it says A, and then on the lines where it says A, and then H, and then K is cut off? Right, K. I love it. I'm so excited. Okay, Thursday at 10 we won't be together.
Man!
I thought we were gonna be like out of semester.
He got so excited.
Yay! I thought you loved me, Manny. I thought we were friends. I don't like that place. Oh no, it's over. Alright, so this says describe how each variable transforms the parent function. So I want you to tell me what A does, what H does, and what K does. Go.
That for every single one.
No, not just generically. What does A do to it?
No, I'm talking like for every single one of the age, okay, right?
No, on the front. This is all I want you to do, the front. Right now, I just want you to look at the front.
Oh, there's that.
When you ask these questions, do you mean what is A doing or
What does A do to this, to a function? To a square root function, what does A do to it? If it's positive, it opens up. If it's negative, it opens down. If you multiply by a whole number, it stretches it. If you multiply by a fraction, it flattens it. So I want you to tell me what A does. Then I want you to tell me what H does. Based on what we learned here, tell me what it does. And what we did in our lesson.
Manipulate.
Does that help?